Now let's solve this question, and it says that t equals, in bracket, 3p raised to the power of 2 minus 4 raised to the power of 3, close bracket. When p equals 2, it is increased by 0.5 percentage. Find the approximate percentage change in t. Okay, now an approximate percentage change in t has the formula that t approximates to the change in t all over the original value of t times 100%. Okay, now but it's very important here also that we find this change in t, or the increase in t. All right, and that by reason of formula we have that change in t, okay, will give us the partial derivative of t all over the partial derivative of p times change in p. Now why I say t all over p is because it involves these two variables t and p. Alright, now for us to find the partial derivative of t with respect to p, now means we are differentiating t with respect to t. And if you take a look at t, that is the equation above, you will see that we will need to resolve this using function of the function, because t is a function of p and y p is a function of itself, having a power of what? 3. Okay, now resolving this using function of function, let u be equals 3p raised to the power of 2 minus 4. Okay, yt then becomes u raised to the power of what? 3, because we've made 3p squared minus 4 as u. So therefore here dt all over du, that is differentiating t with respect to u, you have 3u raised to the power of 2, and differentiating u with respect to p, we get 6p. Okay, so by so doing here we have that the partial derivative of t with respect to p will now be the product of dt and du all over dp. So here we have dt over du, here we have 3u squared times 6p. So we end up having 18p u squared. Now our u here is 3p squared minus 4. So here you have, that will be 18p into 3p squared minus 4. Okay, now that we've gotten dt all over du, now we need to find the change in p. Alright, now take note from the question, p equals to 2, but it is now increased by what? 0.5%. Now let us now find the 0.5% of 2. So that should be, that is the increase in p will now be 2 times 0.5%, which is okay. So here we now have 2 times 0.005 will then be 0.01. Okay, so from this here now we can now say that change in t, which is this formula, now plugging in the partial derivative of t with p, which is this. Here we have 18p into 3p squared minus 4, then times 0.01. Okay, now this is the change in t, which is this. Okay, now let us now plug it into this value here, into this equation here, where t is approximate, since it's approximate percentage. Now change in t, which is the whole of this, that will be 18p then into I guess, sorry, here you have squared, sorry for that, squared. So here we have 3p squared minus 4 all raised to the power of 2, then times 0.01, okay, all over t. Our t here is 3p squared minus 4 all raised to the power of what? 3, then times 100%. Now looking at this, now you can see that we have a common factor in the numerator and the denominator. Okay, now 0.01, okay, 100 times 0.01, that should give us 1 already. Now if you take a look at this here, that the whole of this, take note that this is 3, that is 3p squared minus 4 in 3 places, and this in 2 places. So if you take away, if we eliminate these 2 from here, it implies that we will all remain 1 here. So then our t will now be 18p, okay, sorry, you have 18p all over 3p squared minus 4%. Okay, all right, so to this end now, let us now plug in the value of p to get the approximate value. So here we have that t, that will be 18 times 2 all over 3 into 2 raised to the power of 2 minus 4, taking out percent. So here you have 36 all over. Now here you have 4. Now 4 times 3 here is 12. So this 12 minus 4, that will be 8. So here you have. Okay, so if we were to punch our calculator here, we get that this is 4.5%. So the approximate percentage change in t is 4.5%. Alright, if you love what I've just done, kindly subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos in physics and mathematics. Thank you and God bless you.